Okay, welcome back. This is a little sort of supplementary video. It's a new event. I would say I came across a new application that was related to signal processing and the things we can do with signals, and brings together a couple of my favorite themes, which are music and machine learning and signal processing. So we're going to try and bring all those together and give you again, just an example of what's possible in today's world of signal processing. Now, for this week, you'll also have some exposure to filtering. So this is the idea that you separate out components of a signal based on their frequency. So only their frequency. This is not the same as making it louder or softer overall. This is just separating the signal components and then rebuilding the signal with a subset of those components. So generically, you can see in this image here, we have an original signal, and you could sort of tell there's kind of some low frequency stuff and then some high frequency noise over top of it. And if we pass it through a filter like the one you see described here, which we call a low pass, that is the amplitudes at the lower frequencies are transmitted through, and the ones at higher frequencies are attenuated or damped out. And the resulting filtered signal is a signal that contains the same overall shape of the original, but without those high frequency components that are superimposed on the original signal. And this is a standard filtering technique. Hopefully you'll recognize it at least conceptually if you've never played with one before. So that's filtering generically. There's another type of filtering that we'll talk about in the discussion this week, and that's called filtering based on Fourier decomposition and then reconstructions. This is Fourier filtering or Fourier smoothing. What we have here is an original signal which we separate into frequency components by performing the frequency transform, and that's that second tracing, the one that says spectrum. And then we can adjust that spectrum. We can manually alter it, and then we can transform back again into the time domain, and we'll get a filtered signal. And like I say, we'll go over this in discussion this week, so don't worry about the details of this right now. Because the situation or the challenge that I want to describe right in this video is not separating based on frequency, but separating a mixed signal into its components. Now, the simplest way to picture this is probably this scenario you see here, where there's a bunch of musical instruments. Each of them are playing, and they're playing together. That sound comes out as one collective stream, maybe a stereo stream where you have one sound track in one ear and one in the other ear, but they're not separated by instrument, at least not explicitly so. Source separation involves actually pulling apart those individual sounds, the sound from the guitar, the drums, the keyboards, the voice, and being able to isolate those and manipulate them separately. So this is source separation. Another example of this is when we have a lot of people in a room talking and we want to separate out those individual conversations. If we have, let's say, microphones in that room making a recording of a conversation or meeting, and the resulting sound can be very difficult to separate one voice from another. And so source separation is all about reconstructing the individual elements that made up that merged or integrated sound that we hear in real life as it's being generated. Another theme, I'm sure you've heard about this before, is machine learning. So machine learning has a huge depth to it. There are many courses on our campus to explain more, so I really can't go into detail here. The idea is that it's a part of the AI family. You can see that in this image where artificial intelligence is kind of the bigger picture here. Within that, we have machine learning, and within that, we have deep learning. And each one of them has subtle features. The machine learning approach is one in which we know something about the data that we use to train an algorithm to then perform on new data. So in medical context, we have an image and we annotate those images, whether or not, for example, there's a tumor present in that image and maybe even where that tumor is. And we feed all kinds of examples of that image with the tumor annotated into an algorithm. And that algorithm, based on neural networks, will actually learn how to differentiate between a normal image and an image that contains a tumor, and even help us localize that tumor. That's an example of machine learning. Deep learning does the same basic thing, still based on neural networks, but it isn't coming with all this annotated data. It's not pre-trained, or it's not getting pre-selected, pre-identified, we say annotated data. Instead, it's identifying patterns just based on huge streams of data that go into it. And again, forming an algorithm which we can then apply to new data as it comes along. And that's what we're going to explore today, is the use of this machine learning and deep learning in the context of source separation. So these two contexts, or these two concepts coming together here today. Now, the story that hopefully make it a little bit enjoyable, it has to do with music, and you all know how much I love music. I love the technical aspects of music, and this story goes back to 1974 and a tape that John Lennon recorded. John Lennon, of course, one of the Beatles, recorded a song that he had composed called Then and Now, and it's just him and the piano, and with a microphone placed somewhere, no one knows quite for sure. That tape resurfaced after John Lennon was killed, after he died, and his wife made that tape available to the other Beatles, gave it to Paul McCartney, I believe, and said, you know, here's a new song. Maybe you guys can do something with this. And the Beatles at that time were more or less separating. They were sort of more doing their own thing than really working as a group. But this was a nice opportunity, especially after John died, to see if they couldn't restore this old recording. So they tried. They listened to it, and here's a brief sample of what it sounded like in that original recording. Now you can hear from that the sound quality is really pretty terrible. The relative amplitude of the voice and the piano are not consistent. There's times when the voice just disappears. This really didn't seem to make a very good basis for recording in 1974. And then a few years later, in 1995, the remaining three Beatles, George Harrison was still alive at the time. You see him in this photograph with his back to the camera, and Ringo Starr to the left and Paul McCartney in the back. The three of them came together with that recording and some new technology that they had available at that time in Paul McCartney's own studio, and they tried to see if they could indeed restore that recording. And they added in some of their own tracks, and they tried to mix it, but it just wasn't working. They couldn't use the technology of the time, the idea of frequency-based filtering or anything else they had available to really make enough of a high-quality source recording of John's voice and John's piano. And so they really didn't want to release it under those terms. And now along comes 2022, the era in which we once again hear a lot about AI generally and machine learning in particular. And the image now, or the picture to have in your mind now, is shown in this image, where we again have the mixed sound from all the instruments. And now we have what's called a source separation model. So this is the algorithm that is going to be generated or created by the neural network. So the model generates estimates of the individual tracks. They get compared to some pre-existing sounds, the database, the testing and training, or the training database that the machine learning algorithm has, and that gets refined. And the model gets better and better until it's good enough to successfully separate this original sound into the 3 or 4, in this case, separate voices. And this actually worked, and we'll hear an example of that. So here's the result for On Now and Then of that same recording with, again, John Lennon's voice.
John's voice, crystal clear.
I know it's true. It's all because of you. And if I make it through, it's all because of you.
Now, the amazing thing here, of course, is that there is no trace of that piano. The voice is really pure. There's no other background noises. Even the general background noise in the original recording is just gone. This is kind of magic. And just to show you again an example of how this works, I'll hand the baton over to an artist, a recording production engineer of many years' experience named Rick Beato, who has a fantastic YouTube series. If you're interested in this sort of aspect of sound analysis, music analysis, even from the composition of popular music, he's an amazing resource. And he recently, and this is what caught my attention, came out with a video in which he replicates that same process and shows us how he does it using himself as the subject, recording his own piano and voice together, and then feeding it through one of the source separation tools that are available on the internet today. These are tools you can find and use. And the one he highlights here is Lalal, Lal.ai. And here you'll see how he goes about testing this system on his voice. And I think you'll hopefully be pretty amazed at how well it does. So here we go.
And what I'm going to do is I'm going to actually play the piano and sing that first verse and then show you how I remove the vocal of that stereo audio. Here it is. I know it's true. It's all because of you. And if I make it through, it's all because of you. Okay, I'm going to take that performance, I'm going to put it into this AI program called Lalal.ai and separate that piano and vocal part into two tracks. Here it is. Okay, so I'm dragging the vocal and piano together in it. And what this does is it simply analyzes the two things. It uses machine learning to extract the separate parts. And then we have this. I know it's true. It's all because of you. Now listen to the piano here. I'm going to play the solo of the piano. And this has the vocals over it. It's amazing. Let me switch back to the soloed vocal now. And if I make it through, it's all my bad singing. Because... And then the piano. That's pretty amazing that it can actually separate these things, right? Separate my vocal and piano perfectly. So that's what they did with John Lennon's voice and piano. They actually took out the piano. Paul replayed the piano, he says in the documentary, and then they used George's existing parts from 1995. Paul played a slide part reminiscent of something that George would have done, and Ringo played the drums to it.
Okay, so from that you can hopefully hear just how effective these algorithms, these separation algorithms are, and appreciate maybe just what a breakthrough machine learning and AI have now become in the recording industry. They really allow this restoration of old materials, cleaning them up in an amazing way. And as I said, Lalal is available online. You can go find it and try it out. Of course, there's a fee involved if you use it any amount of the time, like with the modern versions of ChatGPT and other AI generating tools, large language models, all these things. But it's not the only one. There are several other ones you see here that exist. Phonic Mind, Moises, Splitter, Vocal Remover. These are all tools available on the internet that will perform that same task. So it's an open market now to see which one performs the best and where professional musicians and recording people will turn to. And then finally, the results. So I encourage you to go listen to the recording. I think you'll maybe be a little haunted by it. It's kind of interesting to hear the past from 1974 brought into the future with a little bit of addition from 1995 and 96. There's also a fantastic 10-minute or so documentary video on YouTube that describes from the perspective of the Beatles, Paul and Ringo, who were left to make this new recording, of how they use this technology, what it meant to them, and just the process by which it came together. And then, of course, you can literally watch the video, in which they also managed to create some interesting visuals of all four Beatles apparently performing together again. So hope you enjoyed that. Hope you kind of saw how this combination of signal processing with contemporary machine learning AI techniques can really come together to have an impact, not just on biomedicine, but in all areas of science and the arts, of course. And the same sort of tools and enlightenments, if you will, are happening in the visual arts as well, with various tools that will generate images. So it's a fantastic world, and I encourage you to spend a little time doing your own research, trying to get exposed to it. This is technology that you will be expected to know when you head off into your future career. Right, bye for now. Thanks for your attention.